Welcome to Honors Chemistry 2, AP Chemistry. I will be calling them the same. This is a 2-semester year-long class that will match your college introductory class. There is an AP exam in May, and we'll play it as it'll happen. Today I wanted to give you a little introductory notes, and then tomorrow we'll get a little more in-depth and talk more about what the class and what we're going to do. So chemistry is a study of matter. Matter is anything that occupies space or has mass or exhibits inertia. Inertia is the ability to stay still, which means if you exist, gravity in one form or another will pull on you. On Earth, we talk about near-Earth gravity. There's also universal gravity. That's for physics. 100 different types of atoms. We call these elements. An element is a group of atoms with the same composition. Usually defined a little bit better as saying same number of protons. For example, we talk about water. The scientific name for water is water, H2O. So we take water and pass electricity through it. We break it into its elemental forms. We break it into oxygen and hydrogen molecules. The law of conservation of mass exists, so we have 2 and 2. So you can see that this is a chemical reaction. You all know that. And that we should understand a big part of AP chemistry is that reactions can be reversible. So if we take the hydrogen and oxygen gas and ignite it, we end up with 2 water molecules. So the idea that reactions are reversible is a large part of what we're going to deal with in the second semester. The ability to have reactions that are reversible and study their energy and their mechanisms and their equilibrium. So why do we study chemistry? Chemistry is the changes between these. And this is all encompassing. Chemistry is the central science. You can't have any of the other sciences without chemistry. Now, this talks about the Romans and their lead poisoning. Lead is a heavy metal which causes electrical signal damage within the body in large quantities. The Romans used cups and spoons and forks made of lead. The common people used silver. You see that it has reversed. The upper crust used lead, the lower class used silver, and sometimes stainless steel. The idea of chemistry has come about from the idea of changing lead into gold. The ancient chemist science, or pseudoscience, of alchemy was trying to have this happen. We know that this cannot happen. Lead does not turn into gold spontaneously. So the scientific method is what we use. We make an observation. A hypothesis is an idea to explain the observation. That's what we're going to do a lot of here in the labs. Perform experiments. This is a lab-based science. When we return to class, we will have labs. Usually I try to get 26 labs in before the exam that covers all the topics that will be on the exam. This is a lab-based course. Until then, I will be recording the labs, the first few for you. We'll be talking our ways through them. So you've seen the steps in the scientific method. And you've seen this happen in live time. The current situation we're in, this is what is going on in front of us in real time. Now, a theory is the idea that explains a hypothesis. A model is used to talk about if the theory is correct, but it can be changed. The example is Robert Boyle. He invented the first vacuum pump. And what he did was he placed a coin and a feather and allowed them to fall. And he realized they fell at the same rate. He sort of proved that air existed and that gases existed with this experiment. His law we'll talk about when we talk about gases, you may have already seen it, that pressure and volume are inversely related to each other. We'll talk more about that as we go along. The laws we play by are the law of conservation of mass. This is Lavoisier. The law of conservation of energy. The first law of thermodynamics. We can't create or destroy energy either. We can only change forms. This is what we talk about. We change forms or we exchange energies. So that is the big part of what we do in here. 3 types of matter that we talk about: solid, liquids, and gases. We'll talk more about that as we go along. But if you've seen this play out, there is problems. The laws are laws. How we interpret or how we have our bias towards those laws is all these ideas. Let's talk about chemistry. Galileo was the first to build a telescope. He saw the moons of Jupiter, the first 4. And he saw that the moons of Jupiter went around Jupiter. He realized that the sun and the Earth system worked the same way. And that went against everything at the current time. He was imprisoned for his thoughts the last 10 years of his life, but he's proven right. Lavoisier lost his head in the French Revolution. He came up with the idea of the law of conservation of mass. We cannot create or destroy matter. Our nitrates that we are most familiar with, basic one being ammonia, and then all our nitrates, NH4, excuse me, let me rewrite that. To build better explosives, this became our fertilizers. It caused the population explosion after World War I. After World War I, our population did this. And this was one of the main causes, is the use of fertilizers to grow food where it cannot normally be grown. So the units we use in here are the SI units. A system started in 1960. We do use, in the United States, we use both systems. Example is you can buy a gallon of milk or a gallon of gas, or you can buy a 2-liter of soda pop. We've used both systems intertwined. It's to the point we don't understand that they are separate from each other. We have to use our SI units in here, and we use kilograms and meters and seconds and degrees Kelvin. We can use degrees centigrade for some problems. We'll switch back and forth. We use amps at the end. Mole is our main SI unit, and candelairs we don't really use in here. It's more of a physics unit. So these are our SI units. You've known them. We use them other than Celsius. We use a mixed system in the United States. We'll try to keep with metric, but we can switch back and forth a little bit to have an understanding. The way for length, you talk about 1 mile is 1609 meters. That is why in your track and field, you run the 1600 meters, you run the 3200 meters. That's really the old 1 and 2 mile within reason. For mass, a kilogram is 2.2 pounds. English to metric. There's 1,000 grams in a kilogram. You know that. Volume in 1 gallon. There is 3.78 liters. You don't have to memorize these. Liters there. Our prefixes for scientific notation. In the next talk, we'll talk more about conversions and using them. You should be able to use from giga down to nano. Remember that this is 1, 2, 3 exponents, and then 6, and then 9. And then we go 1, 2, 3, and 6 and 9. We'll talk more about these next time when we do unit conversions. Real quick, volume we'll talk about tomorrow. Mass and weight. Mass is the amount of particles. Weight is mass times gravity. Force in physics is mass times acceleration. But when you weigh something, you're really taking the weight, how much gravity is pulling on it. If you weigh a person on Earth and then you weigh a person on the moon, it's going to be 1/6 because the moon is 1/6 the gravitational field of the Earth. Let's see what we got left. We talked about gravity real quick. Gravity is the pull. In chemistry, we don't use gravity a lot. But the idea is that when we talk about weight is really mass times gravity near the Earth. When you weigh yourself, it's the weight, not exactly your mass. And that's what I just talked about. Last thing to talk about real quick is accuracy and precision. Accuracy is how correct you are. What's the right answer? Can you throw a dart and hit the bullseye? That's accuracy. Precision is the ability to repeat. You see that this has no accuracy and no precision. You see that this one has no accuracy, but it has precision. Ability to repeat. Random error, systematic error, we'll talk later on as we start doing labs. But if we look at the last one, this one has, yes, it has accuracy. I've hit the bullseye. Yes, it has precision. So let's look at this last example, and then we'll stop at this point. To check accuracy of a graduated cylinder, a student filled the graduated cylinder 25 milliliter mark using water delivered for a burette. A burette is more accurate than a graduated cylinder, and it read the volume delivered. So we know that we added 25 milliliters exact. A burette is more accurate than a graduated cylinder. You can see that the volume showed by the graduated cylinder does not match the volume from the burette. The burette is more accurate. So if you took 5 measurements from our graduated cylinder, you see that it is off by 1.54. Is the graduated cylinder accurate? Did it read 25? Did it hold 25 milliliters of water? The answer is no. Is it precise? Does it have precision? We can see that these are very close to each other, within basically 1 decimal point. So precision is really not quite there either. If these were all the same to 1/10, I'd go yes. So it does not have precision either. So accuracy is it correct? Precision is it repeated? And that's the difference between accuracy and precision. Just wanted to give you a little introduction. Tomorrow, the next time, we'll talk about SI units and SI conversions and which ones to use.